Hello and welcome to yet another video of Cornerstones of Math. Today I've got you this simple looking limit problem, which is the limit of ln x times ln 1 plus x as x approaches 0 from the right. And of course I am going to show you what I think is the most efficient method, but before we get to that, let me talk about the wrong method first. First, we cannot split this limit into the product of the limit of ln x and the limit of ln 1 plus x. You see, the first term goes to negative infinity and the second term approaches 0. That is, the product of the infinitely large term and infinitesimally small term, which is indeterminate. We cannot definitively tell the value of the limit when the limit is given in this form. You may have learned about these two limits in your basic calculus course, the limit of x ln x and the limit of ln 1 plus x over x. More specifically, you may have evaluated these two limits when you were learning about the famous L'Hopital's rule, since these two are fine examples of applying that rule. Therefore, using this knowledge, we split the given function into x ln x and ln 1 plus x over x. Now let's apply L'Hopital's rule on these two. For the first one, we write it as the limit of ln x divided by 1 over x. So by the L'Hopital's rule, we have the limit of 1 over x divided by minus 1 over x squared, which is equal to the limit of minus x, which is 0. For the second one, the L'Hopital's rule gives 1 over 1 plus x divided by 1, which is 1. Here, you can also use the limit expression for constant e. Therefore, the answer is 0 times 1, which is 0. A quick side note here. Without splitting, you can do it in the following way, changing the given function into ln 1 plus x divided by 1 over ln x and applying L'Hopital's rule. But it is clearly lengthier and more complicated, and it requires applying L'Hopital's rule 3 times compared to at most twice in the previous method. And that's the reason I chose the previous method as the main method to feature in this video. Anyway, that's all for today's video. Thank you all for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.